In this section, we're going to solve systems by graphing, and these are going to be nonlinear systems. So the first thing I'm going to do is I'm going to graph my first equation, which is a circle. And we know from the last section that it doesn't have an h or a k, so hk, our center, is 0, 0. So I went ahead and graphed the center of the circle. And I know that r squared is equal to 25. So our r is equal to 5, our radius. So I went ahead and graphed of those 4 points, and I drew in my circle carefully. So when you're solving the system graphically, make sure you're very careful about drawing it in neatly. My second equation is a linear equation. So we should be pretty good at those by now. So we know that our y-intercept can be graphed first, and our slope tells us to go down 1 to the right 1. Or you could also say it's up 1 to the left 1. Or you could just extend the line. So go ahead and draw that. We know that our solution is where they intersect. So I'll have two solutions. I'll have a solution at 3, -4. And I'll have a solution at -4, 3. And I could check that by putting both those points into my equation. So let's go ahead and check. So if I check 3, -4, so that means in my first equation, it'll be 3 squared plus -4 squared is equal to 25. We can see that's going to check. And then I could check my second point, -4, 3. Once again, doing it in my first equation. And that will also check. Now I want to check my second equation with both points also, because it has to be a solution. Those 2 points have to be a solution for both equations. So in my second equation, I'll say -4 is equal to -3 minus 1, which is true. And then I'll check 3, -4. And that will also be true. So I can check my answers algebraically. The second problem is an absolute value, which I can know from my basic functions. Looks like this. And if I'm not sure, make yourself a little table. It never hurts, right? Put in some points, and you'll see the function will just appear, you know, it'll develop. And our next equation is a circle. We learned that h and k both lie, so I have -5 and 3 as my center. And r squared is equal to 4, so r is equal to 2, my radius. So let's draw that in. You can see I'm going to have 2 intersections here and here. So 2 solutions, one at -3, 3, and one at -5, 5. So let's check both those in our original problems. That's how you can check to make sure you haven't just misread or your graph wasn't exact enough. So let's check first -3, 3. So -3, 3, I can see that's going to be true. And I can also see -5, that one's also going to be true, -5, 5. Now we're going to check our second equation. Replacing the x with -3 and the y with, jump the gun, so 2 squared plus 0 squared is equal to 4, that's true. And then I'll just check that next point, -5, 5, so -5 for x. And +5 for y. And we'll see this is 2 squared is equal to 4, also true. So these are my solutions. Now my next problem asks us, don't do it graphically, it says let's do it algebraically. We can use elimination or substitution, which we've learned in our previous classes for linear systems. And if you're still struggling with those, I gave a couple of problems in the homework problems, and I'm going to put some supplemental videos on our week module, so if you want to go back and review those. But the way elimination works is that you try to find one variable that you can subtract or add vertically. So if we looked at these, if I were to subtract these, my y's would go away, wouldn't they? So what I'm saying is consider this like this. So this side would become x plus 5 squared minus x squared minus 1. And then y minus 1 would become 0. And then negative 2 minus 0 would be negative 2. So I can now solve this because I now have one equation and one unknown. And the way I'd solve that is I would distribute. You can use FOIL or the moon method, whatever method you like. And then over here, I'm going to make sure I distribute the minus to both terms too. Let's make this be a 10x. Now I'm going to look for like terms. Well, x squared minus x squared is 0. And so I'm left with 10x, and 25 plus 1 is 26. So if I want to solve this for x, I can subtract 26 from both sides. And I'll get x is equal to negative 28 over 10, or I can simplify this as negative 14 over 5. If you don't like it as a fraction, change it to a decimal. So we know that negative 14/5 is equal to negative 2.8. So you can use whichever way you like. Now we're going to send that back into either equation to solve for the y. So I'm going to use this one since we already have y isolated. So in place of x, I'm going to write negative 2.8, and I'm going to square it, and I will get, so my x is negative 2.8, and my y is 6.84. And we have to remember this is an ordered pair, and represents the intersection point or points, if we have more than one, for the system. In this case, we only have one solution. Let's try another one. Why don't you pause the video and try it yourself before you see the solution? Now the problem asks us to use elimination, and we know elimination means you either vertically subtract or add, and you eliminate one of the variables. So if I use subtraction, then x squared minus x squared will give me 0, and 3y squared minus y squared will give me 2y squared. And 9 minus 6 will give me 3. This will give me a third equation with one variable, and I can solve that. So I'll divide both sides by 2. And now I'll take the square root of both sides. When I do that, I have to remember I'm going to have plus or minus the square root of 3/2. And this is what y is equal to. Now, I have two different answers, so I'm going to send them each back into the one equation and solve for the corresponding x. So let's first consider when y is equal to plus square root of 3/2. So if I put it back into my second equation, and I'm just choosing that one because it looks a little simpler, but I could choose either one. So instead of y, I'm going to replace it with the square root of 3/2, which is when you square it will become just 3/2. If you don't like fractions, change it to decimals. So I get 6 minus 1.5 is going to be 4.5. I'll take the square root of both sides, and I'll get approximately 2.12. Oh, and I almost fell in the trap myself. Remember, this is plus or minus the square root of 4.5, so it's going to be plus or minus that 2.12. That's the gotcha. So now I have two ordered pairs. I've made 2.12 and then the square root of 1.5, which is equal to 1.22 approximately. Okay, and we said the other one will be negative 2.12, and that will also be 1.22. Okay, so we've considered first when y is the positive square root of 3 halves, and we got two different answers for our x's. Now we're going to consider when y is equal to negative square root of 3 halves, which we already said is approximately negative 1.22. Okay, so we can put that into our original second equation, and it will end up being the same thing. So we'll get when x is equal to 2.12, it can also be negative 1.22. And when x is equal to negative 2.12, it can also be equal to negative 1.22. So the easiest way to think about it is you're doing y equal to negative 1.22, and then you got two answers. That's these two. And then you did it earlier when y was equal to positive 1.22, you got two different x's. So you end up with 4 solutions. So this is our answer. Next, we're going to move on to substitution, and really it's going to be your choice on the test. I'm not going to ask you what way you're going to solve it. It would be your choice. So you could use elimination, and you would be able to eliminate the y squared, right? But we're going to use substitution because some people like that way better. And when we do substitution, we solve for one variable. So in this case, I'm going to say x squared is equal to 10 minus y squared. And I'm going to leave it as x squared because I can see that x squared is in my next equation, and I can just replace that. So instead of negative x squared plus y squared is equal to 8, I'm going to replace that x squared with 10 minus y squared. And now I'm going to just distribute this out, the negative. And I'm going to combine like terms. And I'm going to add 10 to both sides. And divide by 2. And I get y squared is equal to 9. I take the square root of both sides, and I get y is equal to plus or minus 3. But I need the x. I have to solve for the corresponding x's for each. So first, let's look at y is equal to plus 3. So we're going to put it into our original equation of x squared plus, instead of y, we're going to say 3 squared. So x squared is equal to 1. I just said 3 squared is 9. I subtracted 9 from both sides. So x is equal to plus or minus 1. So you can see that this creates two ordered pairs, 3 plus 1 and 3 negative 1. Now I have to also consider when y is equal to negative 3. So once again, I'll put it into my original equation. And I'll get x squared plus 9 is equal to 10. And I'll subtract 9 from both sides. And I'll get x squared is equal to 1. Or x is equal to plus or minus 1. So this will give me two more ordered pairs, negative 3, 1, and negative 3 minus 1. So I end up with 4 answers. Let's do one more with substitution. So in this case, I'm going to solve for x. I always look for the easiest one or one that's repeated in the other equation. So I'm going to replace x with 7 minus y in my top equation. And I'll get 28 minus 4y minus y squared is equal to negative 17. Now this is a quadratic, which means I'm going to have to use either zero factor property or quadratic formula. So I'm going to set it equal to 0 by adding 17 to both sides. And I'm going to rearrange it while I'm doing this so it's a nice standard form. And I believe this will factor. One hint I'm going to give you too is whenever you have a negative in front of your y squared, if you have a negative a, just factor it out. Much easier to factor when it's positive. So I get y is equal to -9 and 5. So I know the y's, now I need the x's to go with each of them. So we're going to consider first when y is equal to -9. I'm only doing half of it. So I'll send that back into my second equation since it's the simplest. X plus, but in place of y, I'm going to say -9. And I'll add 9 to both sides. Oh, sorry, that should be an X. So my first order pair would be 16, -9. But wait, I also have to consider when y is equal to 5. So I'll replace y with 5. Our last skill in this section is graphing a nonlinear inequality. So what you have to think about for this section is just to graph the inequality as if it's an equal. So think of it like this. Okay? Well, we can see that the center for this would be 3, 0. And the radius would be r squared is 25, so r would be 5. And then let's graph that. Okay, so I sketched in the circle. Now, the next thing I want to do is I want to say, this really wasn't an equal sign. It was this symbol, okay, the less than. And we know that it's less than or greater than, we're going to have a dashed line. So let's go ahead and change our circle to a dashed line. We have to remember that if it were less than or equal or greater than or equal, it would be a solid line. So I do that first. The next thing I want to do is I want to look at a test point. Easiest test point to use is always 0, 0. So what this means is I'm going to use 0 for x and 0 for y, and I'm going to test to see if this inequality is true. So I'll replace x with 0, and I'll replace y with 0. And this will give me 9 minus 0, which 9 is less than 25. Since this is true, it means that 0, 0 is a solution. So that means that 0, 0 is a solution. Now, the way this works is it's going to be all or none. So it's going to either be all the inside or it's going to be none of the inside. And in that case, it would be the outside. So this will be our solution for this inequality. Let's look at this same problem, but instead let's consider what if we had a greater than or equal sign like this. How would this change? Well, in this case, we know that our circle would be solid because we know this symbol or this symbol, greater than or equal or less than or equal, we're going to use solid line. And once again, I'm going to use a test point of 0, 0. And this time if I put in 0 for x and 0 for y, I'll get 9 is greater than or equal to 25, which we know is not true. So that means that 0, 0 is not a solution. So if 0, 0 is not a solution, that means that everything on the outside is. So you can see it really is important to notice this sign.